Hi students, welcome back to the new video of the series how formulas were derived. And in this video, we'll see that how area of a trapezoid is half times sum of the parallel sides times the height or the distance between the parallel sides. So here I have two trapezoids with me, this one and this one. So the reason why I've drawn the two trapezoids is because in this video, we will learn this derivation by two methods. And if you haven't watched the previous videos, then I would recommend you to watch the previous videos because in previous videos, we learned about area of a circle, circumference of a circle, area of a circle, area of rectangle, area of parallelogram, area of triangle. And in this video, area of trapezoid, we will be using the formula of area of a triangle and area of a rectangle. So let's get started now. Okay, now here, as you all know that B1 and B2 are the two bases of a trapezoid, or we say the two parallel sides, and this H is the perpendicular distance between those two parallel sides. Okay, so here I have this trapezoid, and first let's do method 1. Okay, so in this method, what I'll do is I will do construction. I will do some construction over here. I will connect these two opposite points, B and D. So then when I do that, I will get a diagonal. This is a diagonal BD. Now, if you observe, this diagonal has divided this trapezoid in two triangles. This is triangle ABD. Okay, so let's say this is triangle number 1, and then you have triangle number 2, which is BCD. Now, if you think about it, the area of trapezoid, ABCD can be written as sum of the areas of these two triangles. So area of triangle 1, or you can say area of triangle ABD plus area of triangle BCD. And we can very easily find the area of a triangle. So let's do that. So to find the area of a triangle, we need its base and the perpendicular distance from the opposite vertex. So first, let's find the area of triangle BCD. For triangle BCD, the base is DC, okay, whose length is nothing but B2, and the perpendicular distance is this. And this is nothing but the original distance, original height of the trapezoid. This is also the distance between two parallel sides. So if I have to write the area of triangle BCD, so that will be half. What is the area of a triangle? Half times base into height. So base is B2 and times height, which is H. Now similarly, if we write the formula for area of triangle ABD, its base can be considered as AB, whose length is B1, and the perpendicular distance or the height will be this, which is again the height of the trapezoid, or we say the perpendicular distance between the parallel sides. This is again H. So the area of triangle ABD will be half times the base is B1 and the height is H. Now, if you observe these two terms carefully, we can factor out half times height. If I factor out half times height, then I'll be left in the parentheses B2 plus B1. So this is nothing but just the reverse of distributive property. In distributive property, you have A times B plus C, which is equal to A times B plus A times C. So I have done just the opposite of distributive property here. And this is what? This is nothing but our formula. Half times B1 plus B2 times height. And that's it. So this was the first method. Now let's look at the second method as well. The second method is a bit complicated, I would say. If you get this method, the first method, then it's absolutely perfect. Now let's just look at the second method as well. Now again, for the second method, I will do some construction. So first, let's name this trapezoid A, B, C, D, where this AB is, let's say, base 1, and this BC is base 2. And the distance between the two bases is nothing but the height. So this is the height between two parallel sides, and also this distance is also the height. Now, why I have drawn these two heights is because this is the construction that I wanted to do over here. Now, I have divided this trapezoid in three parts. There is this triangle. So let's name this point as E, and let's name this point as F. So we have this triangle ADE. We have this rectangle ABFE. Then we have this triangle BCF. Now, what I'm going to do here is I'm going to take these two triangles ADE and BCF, this triangle and this triangle. I'm going to pick up these two triangles and I'm going to join them together. So I'm going to do that here. So this point A and B have combined now. So let's say this is A, this is D, this is C, and E and F have combined now. So let's leave this point. Now this dotted line, this is nothing but the height of the triangle, this length. Okay, now what about the length of the base, this BC? Can you guess what will be the base, BC? You can pause and try to think about what will be the length of BC. Okay, I hope you did that. Now, look at this trapezoid carefully. This entire length DC, here this entire length DC is B2, and this length AB is B1. So this also means that the length from E to F, this length, is nothing but B1. Because this is a rectangle ABFE, and in rectangle opposite sides are congruent. So this EF is B1. So what is the remaining part? Remaining part is DE plus FC. And that is nothing but this length of the base of our triangle. So that can be obtained by subtracting the length B1 from B2. So this length DC here is nothing but B2 minus B1. Okay, now in order to find the area of trapezoid, our original trapezoid is ABCD. That is nothing but area of these two triangles which I have combined over here. So area of triangle ADC plus area of this rectangle area of rectangle ABFE. So now we can easily find the area of a triangle and area of rectangle. So let's do that. So area of this triangle ADC will be half times base, which is B2 minus B1, times the height, which is h, plus area of rectangle ABFE. ABFE is nothing but length times width. Its length is B1 and its height is h. So I'm going to apply distributive property here again to simplify this area of triangle. So that will be half times height times B2 minus half times height times B1, and here this is plus B1 times height. Now if you observe carefully, we have two like terms. This is half times height times B1 and this is B1 times height. Here the variables are same, B1 and h. So these two are like terms. So you just need to subtract this from this. So B1 times h minus half of B1 times h will give us half positive, half B1 times h. So finally we'll get half times h times B2 plus, so this is complete B1 times h and this is half of B1 times h. So I'll get a positive half times B1 times h. And if you observe carefully, this expression is exactly similar to this one. Now again, I can take out half and h common. These are common factors. So in the parentheses, I'll be left with B2 plus B1. And this is the formula that we wanted to derive. So this is the proof of area of trapezoid. I hope you understood both the methods. I know that this method is a bit complicated, but this one was pretty easy. So thank you so much for watching this video. I hope you understood the proof for area of trapezoid. And we'll meet in next video. Till then, bye-bye. Take care.